Hello and welcome to today's lesson. In today's lesson, we'll look at applied chemistry and we'll take a look at raw materials that are used in the chemical industries. Okay. Now, man has been known to make some chemicals for himself, but when we talk of industries, the element after the Middle Age began a revolution of chemical industries. Okay. This actually opened up the field of chemistry more rapidly. At first, it started with what we call the lead chamber process, which is used for the manufacturing of hydrogen tetrosulfate acid. Okay, it was first of all developed, and then a whole new range of other chemical industries later added to it. So the first four that we had, as you can see, as follow. We have the soap factory, we have the acid factories, we have alum factories, and then we have salt factories. These were the four major factories that were opened for distribution of what, or should I say sales of chemicals. Yes, but as demand continued to increase, the chemists had to go into more research. Okay, they had to go into more research. Extensive industrial chemical research saw another discovery of a process known as the Leibniz process for the manufacturing of triazoxide carbonate 4. Is it not? Yes, that was in the year 1791. Is it not? But in the year 1856, William Henry Perkin discovered the first aniline dye. Okay, this was quickly followed by a team of scientists who discovered the Haber process, and the name of these two scientists are actually Haber and Bosch. Okay, what is the Haber process? It is a simple process that combines hydrogen and nitrogen directly to form ammonia, which of course is a very important material for the production of fertilizers. Okay, to look at important raw materials or important chemical raw materials. Okay, they are grouped basically into 8. Now these chemicals are very important because they are the chemicals that are used to produce other chemicals for making other products. Coal, you're already familiar with it. Natural gas, you're familiar with it. Petroleum, you're familiar with it. Salt, which of course is also known as sodium chloride. Then we have limestone, we have air, we have sulfur, and we have metallic ores, which of course is used for extracting important metals. You remember when coal or bituminous coal is heated, okay? It gives coke, is it not? And then the following products, which are coal tar, coal gas, ammonium liquor. The further distillation of this product yields certain chemicals such as your benzene, your toluene, is it not? As you will see in the diagram illustrated below. Now you take a pause and see how these products are yielded all from coal. Okay, for example, when you dissolve that calcium carbide from coke in cold water, you will get ethane, which is a burning gas. Okay, you can see benzene being processed to plastic, toluene being processed to explosive, and then naphthalene being processed to dye. Same goes for crude oil, or what you call petroleum, is it not? Yes, you can see crude oil, that the petrochemical part of it can be processed into different substances. Take a pause and put them down. Okay, I want to explore each of all these chemicals briefly. For example, limestone. We get limestone from rocks and cliffs. Okay, and we obtain lime from it, which is a very important chemical for making cement and also making concrete. All right, remember, limestone is mined. Take note, most of all these chemicals that are listed above, that is the 8 of them, they are mostly mined with an exception of air, is it not? Yes. For salt also, we get salt from rock deposits, what we call rock salt. Okay, now how is salt important chemical? Salt is an important chemical because when you carry out what we call electrolysis of salt or brine solution, the product you get is actually chlorine hydrogen, and then sodium hydroxide. And the sodium hydroxide is a very important chemical for making soap and also used in the petroleum what? Industry. Now, sulfur is a yellow solid deposit, okay? Of course, it is used for the manufacturing of tetraoxosulfuric acid, which is a very important chemical, okay? It is also obtained when metallic sulfide are reduced to metals, okay? Now, sulfur are very useful. Should I say sulfuric acid are very useful? We use them in making explosives, synthetic fibers, and we also use them in making paint and dyes, all right? In nature, sulfur is extracted underground, okay? And then we have sulfur existing as an allotrope, okay? You know your aerobic, monoclinic allotropes of sulfur. What about metal ores? Metal ores are important metals, okay? Such as iron, aluminium, copper. They are what? Extracted from their ore, okay? And these metals are very useful. How are they useful? They are useful in making what? Structures. There's no building you see today without a metal. Is it not? Yes, it's very difficult to see a building without what? A metal, either being the framework of it. The diagram to my right shows how iron is what? Extracted. Of course, the ore of iron is called hematite. You should know that, okay? Most of these metallic ore form their oxides, and so the pure metal is obtained by reducing them, okay? Look at air. Air, of course, is a mixture of gases, as you can see, but contains a higher percentage of nitrogen. Now, fractional distillation of air will give you nitrogen and the other constituents. Of course, this nitrogen is useful in the Haber process, which of course is for the synthesis of what? Ammonia. You should take note, okay? And then ammonia, of course, in return is used in making what? Fertilizers. We also use nitrogen in producing triazole nitrate 5 acid. And of course, okay? You know ammonia is already used in making what? Fertilizers. Let's look at division of the chemical industries. Now, the chemical industry is now defined as one that uses chemistry to make chemicals from other what? Chemical substances. So it's simply an industry that processes chemicals into fine chemicals, and they group these chemicals into two. We have heavy chemicals and then we have fine chemicals, okay? We have heavy chemicals and we have what? Fine chemicals. What are heavy chemicals? These are chemicals that are produced and they are handled in large quantities because of their what? High demand or use every day. The measure of them being sulfuric acid, or what you call hydrogen tetrosulfuric acid, or simply tetrosulfuric acid, okay? It is used in many chemical processes. That is why it is an heavy chemical. Is it not? Yes. From making fertilizer to cleaning, sparkling steel, sodium hydroxide, for making soap and other things, okay? It's also produced in large quantities. Ammonia is another chemical that is what? Manufactured in large quantities. It is also used to make what? Fertilizers as well as what? Explosive, okay? So if you look, heavy chemicals are those chemicals that are what? Produced in large quantities and they are often used. I've given you how many just now? 3 or 4. We have sulfuric acid, we have sodium hydroxide, we have what? Ammonia, then we have what? Aluminium as well. On the other hand, light chemicals are those that are produced in very relatively what? Small amount or quantity, okay? And then purity is also what? Plays an important role. And examples are drugs, okay? And other smaller products, all right? They need a very high degree of purity. That's another difference you can take note of between heavy chemicals and fine chemicals, okay? Fertilizers. What are fertilizers? These are chemicals produced to increase crop yield. It consists of 3 main elements, which are nitrogen, phosphorus, and what? Potassium, in a short form known as NPK. Okay, at times numbers are added in front of it to tell you the proportion in which they are combined. Okay, for example, I'll say NPK 15, 15, 15 means they have equal proportion of what? The element present. Now, the ammonia that is, or the nitrogen that is gotten is from the ammonia source, which is also gotten from phosphorus, and the major compounds are sodium, ammonium nitrate, and ammonium what? Sulfate. At times sodium nitrate is also what? Added to get the ammonia source. The phosphorus is obtained from or is mined, first of all treated with phosphorus tetraoxide 6 acid, okay, to get it in a form that can be used in the fertilizers. It can be converted into superphosphorus, triple superphosphorus, and then tetraoxide 5 acid, okay. This acid can then be converted into what? Ammonium tetraoxide 6. Potassium in the form of several salts is also mined from underground deposit. Potassium compound, nitrogen compound, and phosphorus compound are all mixed together, okay, in most of the fertilizers. And nowadays, the proportion in which they are mixed are usually given as the NPK values. That's why I said NPK 15 15 15. Alright, that now brings us to the end of our lesson. The other activities as usual.